Alright, so moving to the next topic, limit and continuity. Alright, so we already know what a limit is. So let's just start with answering question on limits and continuity. So in this I have 60 questions on limit and continuity. So we're going to solve audio system in this video. Right, so let's start with the first one. Right, so the first question asks us to find the limit of this function when n is equal to 2. So you just have to implement your s to be equal to 2, then you get your answer. That will be 3 um 3 times 2 3 times 2 cube, that is 3 times 8, minus 5 times 2 square. 5 times 2 square is 4, then plus 2 times x, that is 2, minus 7. 3 times x is 24, 5 times 4 is 20, 2 times 2 is 4, then minus 7. So 24 plus this 4 will give me 28. When I subtract 20 from 28, it will remain 8. Then lastly, I subtract 7 from 8. That will give me 1. So my final answer is 1. So the next question, this is also simple. Just implement your minus 1. Since you've tested the denominator, it's not giving you a negative number. It's not giving you 0. So you can um proceed by substituting your s to be minus 1 throughout the equation. So for the numerator, that will be 2s squared. S squared is minus 1 squared, that is 1. 2 times 1, that is 2. 3 times minus 1 will give me minus 3. Then this minus 1, that is my numerator. Then my denominator, that is minus 1 plus 4. So 2 minus 3 is going to give me minus 1. Minus 1 will give me minus 2. So that minus 1 plus 4, that will give me 3. So my answer is minus 2 over 3, which happens to be A. So this is also straightforward. My denominator is not giving me 0, so I can proceed. 3 squared is 9 plus 4 times 3 is 12 minus 5. Then into brackets. My x, I'll be sorry, all over 3 plus 2. My x is 3. 9 plus 12 is 21. 21 minus 5 will give me 16. That is 16 all over 5. That happens to be B. Then the next question, I have to find this when x is equal to minus 2. Likewise, this denominator self, if I put minus 2, it's going to give me 0. So that is minus 2 squared, that is 4 plus 1, 5. That is my denominator. For my numerator, minus 2 raised by 3 will give me minus 8. Minus 3 times minus 2 will give me plus 6, then plus 1. So 6 plus 1 will give me 7. Minus 8 plus 7 will give me minus 1, then all over 5. So B is the answer. So the next one, access to 1. All these are substitution directly. So that is 2 times 1, 2 plus 1, 3. That is 3 all over 1 plus 2. 1 plus 2 is 3. Then everything is by 3. So that is 3 all over 3 is 1 itself. So 1 is by 3 is still 1. So C is the answer. So moving to the next one, I have this. But in this case, when I substitute the value of my sorry. So if I substitute the value of my it started from beginning. Okay, so this is where I stopped for the video first. So right, this, if I put 3 as my denominator, that will be 3 minus 3, that is 0. Also try for your numerator as well. 3 squared is 9, so 9 minus 9 is equal to 0. So once you have 0 all over 0, if you say it's just your denominator that is 0, the numerator is a number. So you say a number, any number divided by 0 is infinity. If you say it's your numerator that is 0, and your denominator is something, 0 divided by anything is 0. So these two have a part. But once your numerator and your denominator is equal to 0, you cannot just simply say undefined. It is called indeterminate. And why is it called that? It can be 0 over 0, can be any number. Do you get it? Like if I say 0 over 0 is just, let me clear this. Alright. If I say 0 over 0 is something, let's call that in n. Then you say 0 is equal to n times 0, like you cross multiply. So this n can be anything. If you say 1 times 0, 1 times 0 will give you 0. That give me a valid answer. If I put 2 there, 0 times 1 times 2, 2 times 0 will still give me 0. So any number, even if you do infinity times 0, but though infinity times 0 can be 0, but not always 0, depending on where you get the infinity from. But generally, any number times 0 is going to give you 0, meaning that this number is a particular number. Do you get it? For that number, that's what you are looking for now. So you can, that give you a clue that this and this contains a component of 3, because for a polynomial, we know that before, if you have a polynomial f of x, if x minus a is divisible by that polynomial, that is f of a is the factor of that polynomial, then s of f of a will be equal to 0. We all know that in polynomial, meaning that if this x square minus 9 should give me 0 when I inputted 3, then s minus 3 is a factor. So you already know that. So you just have to factorize. And of course, this is very easy to factorize. S square minus 9 will give me s plus 3, s minus 3. That is different of 2 square. Then divide by s minus 3. So this will cancel themselves. But mind you, why they are cancelling themselves is not because there is 0 all over 0. So normally 0 all over 0 can never cancel themselves. Don't be deceived. But we are working with limits. Limits tells us that what is the value this is going to approach when s is actually approaching 3, meaning that s is not equal to 3. So s is very close to 3, like 2.9999. So though any value of x, so far x here and x here will be the same thing. So s minus 3 will be the same. So s minus 3 will still give you a number. It can just be small. So since they are the same, they can cancel themselves. That is why we cancel it. So you are left with s plus 3, and s is close to 3. So s plus 3 itself will be close to 6, like that. Do you get? So my answer is 6. Then you can always use L'Hopital's rule when you get to this point, when you have is quite faster in this case. So when you have a polynomial that is indeterminate, whether it's 0 over 0 or infinity all over infinity, these two are undefined. So I mean indeterminate rather. So you can apply your L'Hopital's rule. L'Hopital's rule says that differentiate the up and differentiate the down, then compare it. And once you test it, still giving your 0 all over 0 after you differentiated it, you can still apply L'Hopital's rule. But once it's not giving 0 all over 0 again, that is the end to where you can use your L'Hopital's rule. So this will give me s square minus 9 all over s minus 3. So differentiate s square, that will give me 2s. 9 is out. S minus 3, differentiate s, that is 1. That is, of course, out. That is 2s minus 1. I'll be 2s all over 1. So that will be 2 times 3 is 6. That will give you 6 as well. So this as well, when you put s is equal to 2, that is 2 minus 2 is 0. S cube minus 8, that will also give you 8 minus 8, that is 0. So you can use the L'Hopital's rule. It will be very fast. S cube, when you differentiate it, it will give you 3s square. When you differentiate s, it will give you 1. These two constant, they are out. So that is 3s square divided by 1. That is 3 into brackets. S is 2. So that is 3 times 4, that is 12. For the normal way of doing it, there is a polynomial that says that when you have x cube minus y cube, the same thing as s minus y, then into bracket s square plus xy plus y square. Meaning that this s cube minus 8, you can write it as s minus 2 into bracket, because in this case your y cube is 8, so your y is actually equal to 2. Then into bracket s square plus x times y, so that will be x times 2, that will be 2x plus y square, that is 4. So meaning that you can actually write it like this. So this and this will cancel themselves. Remember I told you, for a polynomial, for s to be equal to 2, give you 0, that means that s minus 2 is a factor. You get it. So that is why it gave us a clue that there is a way we can actually cancel this out, this component inside this whole function. So you just need to do s squared plus 2s plus 4. So s squared is 4, 2s is 4 plus 4. So 4 plus 4 plus 4 is actually 12 as well. So you can use 12. So moving to the next one. Sorry, we have to evaluate the limit as s tends to minus 2. Of course, look at the denominator. It's actually minus 2. Or minus 2 plus 2, that is 0. The numerator, the same thing. Minus 2 cube will give minus 8 plus 8, that is 0. So you can apply L'Hopital's rule, that is faster in this case. And then you can still use the factorization, but let me just keep using the L'Hopital's rule for example sake. So that is 3s squared. When I differentiate this, 8 is gone. Differentiating a constant will give me 0. Then let me differentiate this downward part 1. So that is 3s squared. So minus 2 squared will give me 4. 3 times 4 will give me 12. So my answer is 12 for this case as well. So moving to the next one, as s tends to 1, the numerator and the denominator are 1, 1. So let me use the L'Hopital's rule. When I differentiate s to the power 4, that will be 4s cubed. And when I differentiate x, that is 1. So that will give me 4 times 1 cube, that is 4. So 4 is my answer. This one, I will still apply L'Hopital's rule because the numerator and denominator is 2. If you do 2 square 4 minus 5 times 2, that is 10 plus 6. Of course, 4 plus 6 will give me 10. 10 minus 10, 0. 2 minus 2 in the denominator 2 is 0. So I can apply my L'Hopital's rule. So when I differentiate x square, I will get 2s. When I differentiate minus 5s, I'm going to get minus 5. And the denominator, this 6 is gone. The denominator, when I differentiated s, I'll get 1. This minus 2 is gone. So let me put my x. 2 times x is 2. 2 times 2, 4. 4 minus 5, 1. Minus 1. So all over 1. So my answer is minus 1. So the next one, as s equal to 3. So denominator and numerator is also equal to 3. To cut the story short, s minus, the factor here is minus 3 minus 2. So I already know minus 3 is part of my factor. But instead of factorizing, I can use my L'Hopital's rule as well. So I'll just do 2x minus 5 all over 1. Then 2 is 3. 3 times 2, 6. Minus 5, that is 1. 1 over 1. So my answer is B. So this one too. Let's look at x square minus 4. 2 square will give me 4. 4 minus 4 is 0. All over s square is 4 minus s, that is 4 minus 2. 2. 2 minus 2 again, get 0 over 0. So I can apply L'Hopital's rule. Differentiate this x square minus 4. That will give me 2x. Then this minus 1, when I differentiate it, is going to give me 0. So it's out. When I differentiate x square, will give me 2x as well. When I differentiate minus x, will give me minus 1. This minus 2 is a constant. So when I differentiated it, it's going to give me 0. So I'm just going to implement the value of my x to be equal to 2. So that will be 2 times 2, 4 all over 2 times 2, 4 minus 1, that is 4 over 3. So B is my answer. So moving to the next one, this also numerator and denominator, that is 1 minus 1, this one to 1 minus 1, that is 0 over 0. I can apply L'Hopital's, so that is 3s square all over 2x. This minus 1 and minus 1 is actually out because they are constants. So when you differentiate the constant, it's going to give you 0. That is why I'm excluding it. Of course, this will give me 3x all over 2 because s cancel themselves. So that will be 3 times 1, 3 all over 2. So C is my answer. Moving to the next one, I will ask to find when s tends to 4. So the numerator and the denominator, let me try it. 4 square minus 16, that is 16 minus 16 is 0. So s square is 4 square, that is 16 minus 7 times 4 will give me 28, then plus 12. So 16 plus 12 will give me what is it called? 16 plus 12. It's going to give me 28. Yeah. So this middle term is also 28. So that is 0 over 0. So of course, I'm going to use the L'Hopital's rule, 2x all over 2x minus 7. So I'll put my x, that is 2 times 4, 8. Then 2 times 4, 8 minus 7, 1. That is 8 all over 1. That is 8, sorry, for picking 6. So this, yeah, when you get to this point, you can say apply your L'Hopital's rule. But me, I will not use L'Hopital's rule here. Why am I not using L'Hopital's rule? Because of this square root. Of course, L'Hopital's rule is going to work because if I do square root of 4 minus 2, that will give me 2 minus 2, that will give me 0. Then if I do 4 minus 5, it also give me 0. So L'Hopital's rule can actually work. But it's pretty slower. Why did I know it will be slower? Because I knew that this square root of x, if I want to differentiate it, I will be getting something like 1 over 2 root x, stuff like that. And I want to avoid that. So the best thing I can do is to try to change it a little bit, then apply L'Hopital's rule. So this square root of x is there, this s is there. So I can say square root of x is actually equal to a number because I know if I differentiate a, I'm going to get 1. So if square root of x is equal to a, then x itself is equal to a square. So whenever I see square root of x, I'll replace it with a, and when I see x, I'll replace it with a square. So in this case, square root of x here is a, then minus 2. Then this s here is a square, then minus 4. So the limit has to change. Why? Because s is approaching 4. So if s is approaching 4, then a will be approaching what? A itself is equal to square root of x. So when s is approaching 4, a will be approaching square root of 4, which is 2. So I'll change the limit to s tends to 2. Sorry, to a tends to 2. That is, when s tends to 4, a tends to 2. So now I can use my L'Hopital's rule. Do you get it? So I'll just do 2 minus 2 is 0. Then 2 square that is 4 minus 4 is also 0. So if I differentiate the upper one, I'm going to get 1. When I differentiate 2, that is gone. When I differentiate a square, I'm going to get 2a. Then when I differentiate 4, that is 0, that is off. That is 1 all over 2a. Remember my a tends to 2 now, so that is 2 times 2. That is 4. So of course 1 all over 4 is my answer. So the total works here, but a little bit modification. So this one, so I'm going to use the same approach. My square root of x is equal to something. Let me use y. So my x is actually y square, right? When I square both sides, like square both sides, square root to cancel square, then s is equal to y square. So whenever I see x, I'll write y square. Whenever I see square root of x, I'll write y. So y is y minus 3 all over s is y square, that is y square minus 9. Then I would change my limits because y itself is equal to square root of x and my s tends to 9. That is, my s is square is 9, so my y tends to square root of 9, that is 3. So apply L'Hopital's rule, this will be 1 all over 2y. Then y is 2, that is 1 all over 2 times 3, that is 6. So that is 1 all over 6. So the next one, this, okay. So I have something like this, square root of 1 plus 4x minus 1 all over x. So I can decide to use that same approach. Of course, it's going to work. But at least know that when you're having something related to square root, what should come to your mind is always rationalizing. You can actually use rationalizing for the question I was trying to replace with a before. It's going to work as well. But in this case, I'm going to use the two methods. Let me use the method we are all familiar with before. The one that what inside is this everything that is having square root, I represent it to the number. So meaning that 1 plus 4x, let me say 1 plus square root of 1 plus 4x, let me replace it with a. Then if I square both sides, that means that 1 plus 4x is equal to a square. So what is now my x? My x will be, I'll take 1 to the other side. So that means my 4x is equal to a square minus 1. And I'll divide both sides by 4. So that means my x is equal to a square minus 1 all over 4. So remember this one, a square minus 1 all over 4. So now the question is square root of 1 minus 4x, which is same thing as a, then minus 1. This x is same thing as a square minus 1, then all over 4, right? Then as my s tends to 0, my um my a is square root of 1 plus 4x and my s is 0, I be 4 times 0. So 4 times 0 is equal to 0. So square root of 1 plus 0 is going to give me 1. So square root of 1 is equal to 1. So a tends to 1. So if I do 1 minus 1, that is out. If I this place 2, if I do 1 square minus 1, that is out. So mind you, this same thing as saying a minus 1 divided by a square minus 1 all over 4, so that I don't be confused. So in this case, you can use your L'Hopital's rule because your numerator and denominator is giving me 0. So when I differentiate a minus 1, that is going to give me 1 all over this division sign. This is all over. You can see that it's the same thing. So when I differentiate a squared, that will give me 2a minus 1. When I differentiate 1, that is 0. So 1 is gone. Then divided by this 4, that is there. So that is 1 all over 2a divided by 4. Remember, your a tends to 1. If your s tends to 0, that will be 1 all over 2 times your a is 1. Then divided by 4. So this is same thing as 1 all over 1 divided by 4, right? So that will be 1 divided by 1 divided by 4, something like this. That all over I change to this division sign. So that will be 1 times this division can change to multiplication. If you change numerator and denominator, you interchange it. So that is 1 times 4 all over 1, that is 4. Of course, you can do it in an easier way by rationalizing. You know that when you have x minus y, if you want to rationalize it, you use s plus y. Of course, the answer is 4. Don't forget. So meaning that if I want to rationalize this was there is a which is quite faster, I will use 1 plus 1 this o, then I'll change this minus to plus, right? So that will be square root of 1 plus 4x minus 1, then little bracket square root of 1 plus 4x plus 1. So that is the numerator part, and the numerator part is having x before. That is square root of 1 plus 4x plus 1. Okay, plus 1 as well. So of course you know that when you do s minus y, s plus y, we are going to get s square minus y square. So meaning that when you have two things you want to rationalize, if what is here is x and what is here is y, this will be x minus y like that. This one will be x plus y. So you just need to start expanding. Just know it's going to give you what is here square minus what is here square. So what is here square? That is square root of 1 plus 4x. Square root will cancel square. That will remain 1 plus 4x. Then minus what is here square? That is 1 square. That is 1. So this will cancel this for the numerator. And denominator, we still have s into bracket square root of 1 plus 4x, then plus 1 outside. So since 1 have cancelled themselves, s2 can cancel themselves. This x has cancelled themselves. It now remain 4 all over square root of 4 all over into bracket square root of 1 plus 4x, then plus 1. So this is quite easier for me to put my input now, my limit now. So that will be 4 all over square root of 1 plus 4x plus 1, right? So when your x is equal to 0, so this will turn to 0, 4 times 0, so that is 0. So square root of 1 plus 0, so 1 plus 0 is actually 1. So square root of 1 is going to give me 1. 1 plus 1, then 4 all over 1 plus 1. So that will be 4 all over 2. So 4 all over 2 is actually equal to 2. So that is the answer. Then the next one, let's rationalize as well. That will give me a faster routine. That will be square root of s plus 4 minus 3, then into brackets s square root of s plus 4 plus 3 all over all over oh sorry, it's the numerator that is s minus 5. So s minus 5, we are rationalizing as well. So you still multiply the numerator by the conjugate of this, that is square root of x plus 4 plus 3. Then the denominator will be square root of s plus 4 minus 3 times square root of s plus 4 plus 3. Do you get it? It's because of space I was unable to write it finish. So of course this numerator I'm not touching it. This denominator, since this is s minus y, this is s plus y, so I will like everything that is here I will square it. That is s plus 4. Then everything that is here I will also square it minus what is here I will square it. So that will give me 3. So that will give me um 3 square rather. So 3 square will give me 9. So s plus 4 minus 9 will give me s minus 5. You can see s minus 5 is this denominator that is simplified. It now give me s minus 5. So this s minus 5 is downward. S minus 5 is upward as well. So I'm left with square root of x plus 4, then plus 3. Then I can input my limit now as s tends to 5. So that will be 5 plus 4, that is 9. Square root of 9 is 3. Then plus this 3. So 3 plus 3 is actually 6. So your answer is B, which is 6. But mind you, for this question like this, if you, because of time, might not be able to actually solve this kind of question like this. So from definition of limits, that will give you an edge. What is that definition? Definition of limits tells you that as s tends to 5, this whole function is going to test to something. So your work is now left for you to find that thing. Mind you, though s is not defined at this 5, but for every number tends to 5. Okay, let me say it like this. For every number that is closer to 5, when you do this thing, it will be closer to 6. Your output will be closer to 6. So just input a number that is closer to 5 and then put it in this function. Then if this limit is actually true, then you should actually get a number close to 6. So for in this case now, the s is close to 5. Why can't I use 5.01 or use 4.99 or something like that in my calculator directly? And then if I do that, it will give me a number very close to 6. Then I'll pick it as my answer. So let's try that. That is s minus 5 all over square root of s plus 4 minus 3. So let me go to my calculator and try that. Hope I remember those values. So of course you can see now it's 4.99. I took my s to be closer to 5. 4.99 is very close to 5. So 4.99 minus 5 all over, then my s is 4.99 here plus 4, then minus 3. So if you actually input it well, you see I got 5.998. So that is quite much easier for me. So I know my s is approaching a number which is approximately 5.998, which is the closest one is actually 6. So I already know 6 is my answer. Let's move to the next question. Mind you, this work for every limit. So just input whenever you see a question on limit. So because of time, you can just use that. But that does not mean you should not know how to actually do it in the right way. So this one too, you can literally do the same thing. A number close to zero, like 0.01, or a number close to zero, like 0.01. These two they are close to zero, so they will both work. Just use a number close to zero, and mind you, the more your number is close to zero, the more your answer will be close to what you are looking for. Do you get it? So let me just use the calculator as well for this question. Square root of 4 plus x minus 2, then everything all over x. So let me use 0.01 in this case. So I'll go to my calculator. Nice. Sorry, that is square root of um so that is 4 plus x, that is 4 plus 0.01 minus 2, then all over x. I also take it to 0.01. What did I get? 0.249, and I know that is very close to 0.25. That is 1 over 4. So 1 over 4 is actually my answer. So the same approach. So you can decide to use your normal method if you wish to. So 1 over 4 is the answer. So the next one, we can use the same approach. We can actually expand anyhow sha, but in this case let me just expand it. I will quite be faster. I will not show what case, but you can actually try it on your own just to pick the answer sha. That will be 1 plus x minus 1 plus x, that is 2x, then x will cancel themselves, then 2 over 1 plus 1, that is 1. So my answer here is 1. We will test it whether you use a calculator or stuff, you get 1 sha. So this one too. Okay, so we move to the next phase of this part. Sorry, let me um make it brighter. So in this next phase, so this the meaning of this one is like, if you want to test a value, you should test a value that is, that although normally, usually, the limit, if the limit exists, both 2 plus and 2 minus will give you the same thing. So when they set s approaches to, the meaning is that s can go into parts. It can go into in positive way, and it can go into a negative way. Two in positive way means number close to 2, but in the positive way like 2.1, 2.01, like that. And this one that is 2 minus is like 1.99, 1.9, number close to 2 but going in the negative direction. So you can literally test 1.99 in this case or something like that. So if you do 1 all over 1.99 minus 2, so that will give me sorry, let's try that. 1 divided by 1.99 minus 2. We are getting 100. What does this 100 means? Compare this 1.99. See this 100. It's a very big number. Meaning that if I keep using a smaller number like 1.999, if I use something like this, you see it increase to 1000. When I do it, all these things they are close to, they are still close to 2. Meanwhile, they are giving me something close to 1000. So meaning that they are pushing a bigger number. That means you are pushing infinity. And what do you note? You know that for each number, this number, they are having negative in front. So meaning that they are not just approaching infinity, they are pushing negative infinity. So Kini is the answer. B is the answer. Do you get it? So you can also do it like do it normally. Just put 2 here, like 1/2 minus 2. So this numerator is a number, so you don't care. It's only the denominator that is zero. So anything divided by zero is infinity. It's not like indeterminate that we have been working on. You can only say it's indeterminate if two of them, numerator and denominator, is equal to zero. But remember, they said 2 minus, that is 2 in the negative way. So it's approaching a very bigger number, but in the negative sense. So B is the answer. So the next question, in the 2 plus way, so you do 1 all over 2 plus 2 minus 2 will give me 0. So 1 over 0 is infinity, but this approaching 2 in the positive way. So the result will also approach infinity in the positive way. Or you can use a calculator. So that will give you plus infinity as well. So moving to the next one, as s approaches 3, 1 over s minus 3 all squared. This numerator is 1. So don't be deceived. So that will be 1 all over this 3 minus 3 is 0. 0 squared is still 0. So 1 all over 0 is infinity. So it's actually approaching infinity in the positive way. Do you get it? But in the negative way, it's not approaching infinity. When you see infinity, look at if it is in positive way, it will be plus infinity. If it is negative way, it's minus infinity. So is approaching one thing in the positive way, another thing in the negative way. So you say the limit does not exist. So let's just use our calculator to verify that. They say it's close to 3, abi, so I'll use a number close to 3 in positive and negative way. So that is 1 all over my x is something close to 3. Let's say limit first is 2.99 minus 3, right? Then square it. This one I get 10,000. Okay. The limit is 0, abi is infinity. It's not approaching infinity in both ends. But that is why it's best. If you don't really understand the concept of how you know if it is positive infinity or negative infinity, just test value. Give this will give you a very big number. Meaning that if you keep decreasing you keep making your s very close to 3, the number will be increasing. So this is approaching positive infinity. So let's now use a number that is close to 3, but it's actually greater than 3, like 3.01. This one too, this one give me 10,000. When I add 1 0 to it to make it more closer to give me 1 million. Can you see it's very bigger? Two of them they are approaching positive number that is bigger. So two of them are approaching positive infinity. Why I make that mistake is because that normally um that is positive infinity. But why the mistake is because um this s minus 3 in the negative is approaching negative infinity, in the positive is approaching positive infinity, but because it is squared, so this square will swallow the minus, like minus times minus is plus, so that is why it's like that. So it's not does not exist, it's a. So in this one we should find the limit when s tends to 0. So let's use a very big number, a very small number first, like it tends to 0. Let me use minus 0.01 divided by 0.01. Of course, this will cancel the minus, like you swallow the minus, that is 0.01 over 0.01. So this approaches 1. So let me now use a positive number. So when I use a positive number, like 0.0, oh, sorry, there was a mistake here. This minus 0.01. My s was supposed to be minus 0.01 as well. So this will give me absolute value, remove the 0, 0.01 all over minus 0.01. So this will cancel. I'm left with minus 1, right? So this one is approaching minus 1 in the negative end. So in the positive side, that will be absolute value of 0.01 all over 0.01. So that will give me 0.01 all over 0.01. That is 1. This one is approaching 1 in the positive. This one is approaching minus 1 in the negative. That means we say the function is not continuous. So and if the function is not continuous, it means that the limit in the positive and the negative are not the same thing. So the limit does not exist. So that is why D is actually the answer. So the next one, this we asked to find f of x. They said that this is just testing on your ability to know the law of continuity that says that s tends to a in the negative side and you do f of x, you get 5. S tends to A in the positive side, you do f of x, it also give you 5. That means that the limits exist at that point. The limits when s approaches A, do you get it? In the negative and the positive are the same. So the limit exists and the limit is that same 5. So the answer is 5. So s tends to infinity of this one. So when you see any question on s tends to infinity, that is the normal way of solving it, is by saying numerator and denominator divided by x, then s minus 2, you also divide by x. So this 3x divided by x will give me 3 minus 1 over x all over s divided by s will give me 1 minus 2 all over x. Of course, you know that if s tends to infinity, what is the meaning of infinity? Infinity is a number that is very, very big. Do you get it? I've explained that. So now imagine you doing 1 all over a very, very big number. Of course, you are going to get a very, very small number. So, but the language for it in limit is tends to 0. A very, very small number is a number that tends to 0. Imagine you doing 1 all over 1 million. You are going to get 0.0000000. You get it? So that is very close to 0. So meaning that 1 all over x will be close to 0. So everything here will be 0. So I will left with 3 all over. The same thing, 2 divided by a very, very big number will give me, because my s tends to infinity, will also give me a small number. So this will also be swallowed as well. Just know that if s tends to infinity, 2 all over s tends to 0. So this is 3 all over 1. So my answer is 3. And then you can also say, okay, s tends to infinity. And you know, infinity, 1 all over 0 or anything all over 0 is actually equal to infinity. Do you get it? So that means that when you say 1 all over infinity is actually equal to 1 all over x. That is, if you, I'm going to explain this. Let me say s times 1 is equal to infinity times 1, right? So take infinity to the other side, it will become 1 all over infinity. Then take s to the other side, sum 1 over x. So infinity is out, s is out. So that is 1 over 80 is equal to 1 over x. Do you get it? And you know that your infinity is actually 1 over infinity will be 0, of course. So you know 1 over x is equal to 0. So anywhere you see anything that is 1 even 1 over x or 1 over x square or so, will give you 0. But in the exam, I don't expect you to do this. What I expect you to do is just to pick the highest value here and the highest value here. Then divide the coefficients. Since you know that the remaining one will actually cancel out due to the infinity part. So that is just be 3 all over 1. So we use that in when we see similar question here. So okay, thank God I see a question here. This is 5x squared, this is 2x squared. You already know this one will have all over x, this one will have all over x squared, this one will have all over x squared. So anything divided by infinity, everything will give me 0. It's only this one that if I divide everything through by x squared, this one will remain 5, this one will remain 2. So all I just need to pick is pick the biggest coefficient. Look what the one that have biggest power. Then pick the coefficient. This one, the coefficient is 5, the coefficient is 2. Then my answer is 5 over 2. Sorry, so this one too. But in this case, you can see this one, the highest power is 4x squared. The highest power here is s cube. So you can say that this 4x squared plus 3 is the same thing as 0s cube plus 4s squared plus 3. This 0s cube is actually 0, so it's not affecting everything. Meaning the highest power, the coefficient of highest power here is 0. The coefficient of highest power here is 1. So 0 over 1 is 0. So the answer is 0. Do you get it? So the next question, 7x cube and 2x cube. The highest power, the coefficient is 7 here, is 2 here. So the answer is 7 over 2. So that is B. So the next one, this one too. The highest power is 3. The highest power is the highest power is 2. So this coefficient is 3. This is 1. So 3 all over 1 is 3. Okay, I was asked to find horizontal asymptotes. Okay, so what is the meaning of asymptotes? The meaning of asymptotes is a path where the function cannot pass through. And what does that mean? We have two types of asymptotes. We have the horizontal and the vertical. So sorry. So when you have a place where your y is not defined, you will always have asymptote there. That is, this thing we used to do, that I will say that our s does not be equal to 0. Denominator must not be equal to 0, because if denominator is equal to 0, any number x divided by 0 is infinity. But once the denominator is equal to 0, we will not have any answer. That is that the function is not going to pass to that point. That means that one that we used to do is actually a vertical asymptote. Do you get? To make it easier for us to understand, let me find a function like um y is equal to 1 over x. We know that when s is equal to 0, this function cannot be defined. That is that the function is always like this. Y is 1 over x abi. So as s tends to 0, when s is equal to 0, y tends to infinity. The graph always look like this. Graph of 1 over x, this is how it looks like. So it's just like when s is equal to 2, you get a value for y. When s is equal to 1, you get a value for y. But when s is equal to a number that is close to, sorry, when s is equal to a number, let me draw it again. Is a number that is close to 0, you'll be getting a value. Do you get it? You'll be getting a value, even though the value will be increasing. So, but exactly when s is equal to 0, the graph cannot pass through it, because there is no how you can have 1 over 0 to give you a particular value of y. So this graph will be getting close to the y-axis, but it will never touch the y-axis. So that is why we call it a vertical asymptote. So it's actually approaching the vertical axis but never touching. It's actually approaching something in the vertical axis but never touching that thing. So at s tends to 0, that means that it's going to meet because as it's getting close, we assume that it's going to meet at that point, one point, and that point is going to meet is the infinite. That is that the just plain English is that it's not going to meet anywhere until unless if you can get to the number called infinity. Then when it gets to a number called infinity, then it can meet infinity there. So that is why we say y tends to infinity. So if you want to write the vertical asymptote of this function, you say that s is equal to 0. That is that this line, you know that this straight line, this vertical line is what the function is approaching, that it will never touch. And I told you that when you have a vertical line, it's always s tends to 0 something, but you already know that this x is at the origin, so the x coordinate is s 0 to 0. So but for horizontal asymptote occur when is when s tends to infinity. You know that for horizontal is when y tends to infinity. We can calculate it that okay, for this function when y tends to infinity, so is when y tends to infinity, we will now find the function that s tends to. That will also give us the function. Do you get it? Or when y is undefined, whether you say undefined or tends to infinity. So in this case, if we want to find our vertical asymptote, we want to do for value of y, that is the value that y will be approaching when s tends to infinity. If you want to rephrase the statement, we say that the value that when the s is equal to that value, your y will actually be approaching, sorry, when your y is equal to that value, your s will be approaching infinity. That is, your s will not touch that particular y, it will just be approaching that y. The same way, the way I demonstrate that your s is just approaching that vertical line, is not touching it. So just know that for your vertical asymptotes, your y will tends to infinity and your s tends to 0 for that exact one I gave you. But generally, when you hear vertical, y tends to infinity. When you hear horizontal, s tends to infinity. That is the general stuff I can give you. Vertical is y axis, it tends to infinity. Horizontal is s axis, it tends to infinity. So let's look for the value when s tends to infinity. I already told you that just pick the highest value here and highest power. Okay, highest power and highest power, then the coefficient, divide it. So y actually tends to 3. So that is where you have your asymptote. That means that this graph can never pass through the point where y is actually equal to 3. Do you get it? So of course, C is the answer. So limit as s tends to 0 of this is a normal stuff. You can use it two ways. You can use the delta zero. You can use all this Maclaurin series or anyhow sha. This is a proper derivation that sin x all over x is actually equal to 1. If you want to use your delta zero, when you differentiate, because you know sin 0 is 0, s is also 0. So when you differentiate the upper part, So when you differentiate sin x, you're going to give you cos x. When you differentiate x, you're going to give you 1. So cos 0 is 1, then 1 over 1 is 0. I mean, is 1 rather. So B is the answer. S tends to 0 of this. Already, you know that sin x all over x is equal to 0, right? Is equal to 1, right? So meaning that sin 5x, let's say my sin 5x, let me say my u is equal to 5x. There's a reason why I'm doing that. So that means that if my u is equal to 5x, so that means that if I divide both sides by 5, so my x will be u all over 5. So I can replace this x with u all over 5. Then let me test. I will have to change my limit. When s tends to 0, u tends to what? So u is actually 5x. So when s is equal to 0, u is 5 times 0, that is 5. That is 0 as well. So u also tends to 0. So I can find limit of as u tends to 0 of this. Do you get it? So sin u all over u divided by 5. The same thing as saying sin u all over, oh, okay, let me change this all over to this kind of all over so that I not be confused. So it's same thing as sin u times 5 all over u. So this sin u all over u as u tends to 0 is 1. So that is 1 times 5, 5. So the answer is 5. Do you get it? But just know that this sin 5x, you want to make it the same thing. This x is also here. We want to make it 5x. So you have to multiply you have to multiply the denominator by 5 already. So you have to multiply the numerator by 5 as well to make it balance. So this sin 5x all over 5x is now like the same, but you need to verify that as s tends to 0, what the 5s tends to? 5s also tends to 0. 5 times 0 is also 5. So you can use it. But if 5s does not tend to 0, if it tends to another thing, you cannot use that you cannot use it. I'll give you an example when we proceed. I think there is a question that can demonstrate that. Yeah, there should be a question. Yeah, so this is 1, then this is 5. So that is it. So the next one, tan, these are major stuff you should know. Sin x all over x is equal to 1. Tan x all over x is also equal to 1. E raised by x minus 1 all over x is equal to 1. I think in x all over x is also equal to 1. I guess so. But just know this stuff. And another one, 1 minus cos x all over x is also equal to 1. So know this. And you can always use your left rule. So it's quite easier. So tan 4x, just tan 4x. This x, I want to change it to 4x as well. I will multiply the numerator by 4 as well. So tan 4x all over 4x. But let me confirm the limit. If two of them, when s approaches 0, 4s approaches 4 times 0, that is also 0. So it's also approaching 0. So this is acting as a unit. Tan s all over s is, when it approaches 0, is actually 1. So meaning tan 4s all over 4s, since 4s is also approaching 0, so that will give me 1. So that is 4 times 1, 4. So that is 4. This one too, this one is sin 3x all over sin 4x 5x. So to make it easier, this is what I'm going to do. I say that I should do it something like this. Sin 3x all over, like the numerator and the denominator, divide both of them by x. But that is quite not, how will I say, that is quite slower. It's the same thing I'm actually saying, but when they say that sin x all over x equal to 1, what are they trying to say? They say sin x all over x as s tends to 0 is approximately 1. That means that you can say sin x is actually equal to x, or is approximately equal to x as s tends to 0. So meaning that when your sin x tends to 0, that means that you can actually replace your sin x with x, because their ratio is equal to 1. That means they are approximately equal to each other. So in this case, we have sin 3x. That means that it's approximately equal to 3x. And you have sin 5x is approximately equal to 5x. So 3 all over 5 is the answer. So the next one too, 1 minus cos x. I was giving you this relationship before, that 1 minus cos x will actually give me all over x will give me 1. But in this case, if you still have 1 all over x like that, and 1 all over 0 is infinity. Of course, the answer is not infinity. So what do? when you have trigonometry like this, just try to rationalize it. This is 1 minus cos x. Multiply by the numerator and the denominator by 1 plus cos x. Cos and sine always have something interesting. So numerator and denominator by 1 plus cos x. So 1 minus cos x times 1 plus cos x will give me 1 minus cos square x. Then all over x square 1 plus cos x. So 1 minus cos square x is sine square x. So I now have sine square x in the numerator all over x square, then 1 plus cos x that is there before. So that will be sine x, sine square x same thing as sine x times sine x. So this is like saying sine x all over x times another the second sine x again, sine x all over x, then multiply by 1 all over or 1 plus cos x. That is, I just separated this. This will give me 1, this will give me 1. 1 all over 1 plus cos x, that is what I have left. And cos 0 is 1. So 1 all over 1 plus 1, that is 1 over 2. So my answer is 1 over 2. But mind you, you can always use your calculator as well. The trick I told you that you should put a number that is very, very close to 0, like 0.01 or something into your function. It's going to give you, but make sure you set your calculator to radian when you are using that, because your trigonometry stuff for this limit is always working with radian, not degree. So if you want to test this one, make sure you are using radian, not degree. Do you get it? So let's move to the next question. That is this one as essential zero. So this is very similar to the one I did before. If I rationalize this upper one, it will give me 1 minus cos square 4x. And if I do the same thing for the denominator, this or let me just use the octave rule, that will be faster. When I differentiate one, it will give me 0. When I want to differentiate cos x, I'll get minus sine x. So if I want to differentiate cos 4x, differentiating to make it faster, when you have function inside the function, just know that this function 4x is differentiable, is changing. So if you differentiate 4x, you get 4. And take this one as a whole. You differentiate cos x, you are going to get sin x. So if you want to write it, this 4x is changing, and when you differentiate what is changing, it gave you 4. Now take this minus cos as a whole, like you are differentiating minus cos u, something like that. It's going to, when you differentiate minus cos u, you are going to get sin u, because minus and minus you cancel. This cos u itself will give you minus, and then this minus that is here will give me minus as well. So that will give me sin u, where your u is equal to 4x. So you can, u is acting as a whole now. You have first differentiated it. This u itself, you have first differentiated. That is product rule. But just know that you differentiate what is here and you differentiate this as a whole. So that is sin 4x. This one I've go. When I differentiate x square, I'm going to get 2x. Do you get it? So that is 4 sin 4x all over 2x. Do you get it? Yes. Differentiating, yes. That is correct. So put your x to be is equal to 0. So when I do sin 4, but wait, sef, I don't need to stress myself. I know that as s tends to 0, my sin 4s is approximately equal to 4s. That thing that I said before. So that this can be like 4 times 4s all over 2x. So s will cancel them. So that is 4 times 4 all over 2. So 4 times 4 is 16 all over 2. That is 8. So I can even pick 8 directly like that. Do you get it? So moving to the next question. So for this workshop, I also give you that I told you sin x all over x is equal to 1, and I said 1 minus cos x all over x is equal to give me 1, meaning that 1 minus cos x is approximately equal to x as x tends to 0. So 1 minus cos 2x all over 2x will also give me 1, because if I do, when my s approaches 0, 2x will be 2 times 0 is also approaching 0. So they are the same thing. This will also hold, meaning that 1 minus cos 2x will be approximately equal to 2x. So I can just replace this 1 minus cos 2x with 2x, because they are approaching the same thing as s tends to 0. So this will give me 2x, then I have x all over sine. This sine 2x is also approaching 2x. You get it? So this was supposed to cancel this cancel. The x tends to 0. Then I should have something like x is equal to 0, but it's not in our answer, meaning that the approach is not working here. So let me do the right step. Rationalize. This 1 plus 1 minus cos 2x. Let me multiply both numerator and denominator by 1 plus cos 2x. Meanwhile, so that will be x into bracket sine 2x into bracket 1 plus cos 2x all over 1 minus cos 2x times 1 plus cos 2x. Do you get it? So this 1 minus cos 2x times 1 plus cos 2x is a 2 square, something like this, x minus y, x plus y, which is going to give me x square minus y square. So if this is x, this is y, so I will square this. That is 1 square 1 minus square of this, that is cos square 2x. So that is for my denominator. For my numerator, I'll just leave it like that. So this 1 minus cos square 2x, 1 minus cos square theta is same thing as sin square theta. So this is same thing as sin square 2x. Do you get it? So that means that I have x all over s sine 2. Oh, let me write it again. S sine 2x all over sine square 2x. Sine square 2x is same thing as sine 2x times sine 2x, like sine 2x twice. And remember that in the numerator I have 1 plus cos 2x. So of course this cancels this. I know that I can now use that approximation stuff, that I know that I think this 1 minus cos 2x, you should avoid replacing it with x. I think I'm replacing it 2x. I think maybe probably that is where the error come from. But this sin x, this have cancelled themselves. This sin 2x is approximately equal to 2x when x tends to 0. I think that that would be 2x like that. You can replace your sin x with 2x as it tends to 0. Then you have 1 plus cos 2x again. 1 plus, let me write it again, cos 2x. Sorry for the bad handwriting. Yes, we cancel them. So we'll be left with 1 times 2 multiplied by 1 plus cos 2x. Of course, cos 2 times s is 0, 2 times 0 is 0. So cos 0 is 1. So that is 1 plus 1. So that will give me 1 plus 1 will give me 2. So 2 all over 2 will also give me 1. So my answer is 1. So the next question, x sin x minus tan x all over x cubed. So as to find it. So the best thing I can do is to use our Maclaurin series of that of sin x and cos x and sin x and tan x. Of course, we are not really familiar with that. So let me use my doctor's rule, or I should use something else. So let me use okay, I can even do it like this sef. That will be quite easier. Sin x same thing as sin x, tan x is same thing as sin x all over cos x. I'm still working with the numerator, so um taking the LCM, this is actually the same thing as um like I want to take the LCM, this is the same thing as saying sin x cos x minus sin x all over cos x. I take the LCM. Do you get it? So this is the same thing as all over 1. So cos x divided by 1 will give me cos x. So times this sin x, that is how I have this. Cos x divided by cos x will give me 1 times this sin x, that is how I have this. So of course sin x is common, so you can say sin x into bracket, this one will make cos x, this one will remain 1, then all over cos x. Do you get it? That is what I simplify my numerator to. Then add my denominator to it, which is s cubed. Do you get it? So I will now rationalize now for this cos x minus 1 factor that is here. I will rationalize it. So I'll multiply both the numerator and denominator by cos x plus 1. So now, remember I have sin x all over cos x. Then multiply by the denominator is having x cubed before. Then this way I'm having cos x minus 1. So I multiply by cos x plus 1. This place cannot contain it. Let me rotate my stuff. So I've simplified the method to be cos x all over. Okay, is this cos x over sin x? No, it's sin x all over cos x. Sin x all over cos x. Then multiply by cos x minus 1. Then everything divided by x cubed, right? So I multiply both. I want to rationalize. I multiply both numerator by cos x plus 1, and then this also by cos x plus 1. So of course cos x minus 1 times cos x plus 1 is in form of x minus 1 x plus 1. So this should be cos square x minus what is x plus. That is cos square x minus 1. So cos square x minus 1 will give me sin minus sin square x, because 1 minus cos square x will give me sin square x. So when I do cos square x minus 1 will give me minus sin square x. Of course, that is what I want to achieve. I want to make my s to be appear 3 times, so that s all over sin x all over s will appear like that. That is what I want to achieve. So now this is achieved already. So this sin x all over cos x there before, and I've gotten my numerator to be I've gotten it to be 1 minus sin square x all over s cube. Then remember this is already having cos x plus 1. You get it? So this sin x all over 1x, this sin square x is sin x and sin x. So each of them will be sin x all over x, sin x all over x, sin x all over x. 3 of them will give me 1, 1, 1. So that will be 1 times 1 times 1. This one remain all over cos x. And do you get it? Then the denominator itself. Let me write it very well. Sorry. But of course, let me just simplify it so that I will not be confused. Before is sin x all over cos x. And so just the numerator, let me simplify it with sin x times minus sin square. So that is minus sin x times sin x all over. This one is having cos square. That cos square can just go down. You get it? That is the cos. Okay, it's not cos square, it's just one cos. Then 1 plus cos x, or cos x plus 1 is same thing. Then s cube is s times x times s. So s times s times s, one sin s will have that x, another sin s will have that s, another sin s will have that x. With this minus that is in front, that will be minus 1 all over. Then I'm left with cos x all over 1 plus cos x. Because 0 is 1. Into bracket 1 plus cos 0, which is 1. So 1 plus 1 is 2. So that is minus 1 all over 1 times 2. That is minus 1 over 2. So my answer is actually A, which is minus 1 all over 2. But to save you this stress, it's quite long. You can use your calculator to actually do this. I think calculator self can find limits. That is the easiest basic thing sef. So you can always bypass all this stuff. And then I told you that e raised by s minus 1 all over 1 as s tends to 0 is always 1. So you don't need to solve this. That is e raised by s minus 1 is very close to s as s approaches 0. So this is P. So if e raised by x all over s tends minus e raised by s minus 1 all over x, let me write it so that you don't be confused. So you have e raised power x minus 1 all over x is approaching 0. So that means that e raised power 3x minus 1 all over 3x will approach 1 as well. How do we know? First of all, when s is approaching 0, is 3s approaching the same thing? Let's test. 3 times 0, 0. So they are approaching the same thing, meaning that e raised power 3s minus 1 all over 3s as well is going to give me 1. Do you get it? Meaning that e raised power 3x minus 1 as s tends to 0 is very close to 3x. So I can replace it with 3x. So this e raised power 3x minus 1, I'm just going to write it as 3x because it's very close to that, and I'll divide by this x. So my answer is 3. So the next one, so 2x minus 1. But I know e raised power 3x is actually minus 1 is actually equals to x as s tends to 0. So what can I do? So you can actually use the Octazone, but trust me, it's very stressful for this kind. Okay, it's straightforward, sha. It's straightforward. When you differentiate these two x, you are going to get 2 raised power x into, right? That is very straightforward, to be candid. Then when you do 2 raised power 0, you are going to get 1. That is into. So you can use your L'Hopital it's faster. So when you do 2 raised power x, when you want to differentiate 2 raised power x, you first, normally if you want to differentiate raised power x, it will still give you raised power x. But if say it's any number apart from e, it will be in of that number. It's because that in of 2, in of e rather, if you say is e raised power s, it will have been in e. In of e is log e base e, which is 1. That is why it doesn't have anything. But once you are doing it with any number raised power x and that number is not e, it will differentiate the number, then you add in of that number to the front. So 2 raised power x will give me 2 raised power s, then in 2. When I differentiated 1, is gone. When I differentiated x, that is it. Then as s tends to 0, 2 raised power x will be 2 raised power 0. 2 raised power 0 is 1. So 1 times into is into, then all over 2, that is into. That is faster. So you can use that method. E raised power 2s minus e raised power x all over x. This e raised power 2s is like saying e raised power 2x. It's like saying e raised power x raised power 2. For my law of indices, like e raised power x times e raised power x will give me e raised power 2x. Do you get? So like my law of indices, right? So e raised power x is common. This will remain e raised power x minus 1 because it's common. This one we have e raised power x 2 times. This one have just 1. I remove 1. This one remain 1. This one remain nothing. Then all over s. Of course, I know as s tends to 0, e raised power x minus 1 all over s will give me 1. So all this one like this have given me 1. So e raised power x is my answer. But what is e raised power s? That is e raised power 0. That is 1. That is also 1 times 1 times 1. That is still 1. So 1 is my answer. So the next one, as s tends to infinity. This is the proper definition of e. You should know this, that is either they used to write it two ways. 1 all over 1 all over x all over x. Limit as s tends to infinity. That is the definition of e. Or they should write it as this: s limit as s tends to 0 of 1 plus x all over 1 all over x. That is our answer. So let's move to the next one. I have limit as s tends to infinity of 1 plus 3 all over x as raised power 3 all over x raised power x. We know that limit of 1 plus 1 all over x, why is this not writing? Raised by x as s tends to infinity is definition of e. So what of if it is 3 all over x? So this is what I'm going to do. So 1 all over x times 3, as s approaches 0, this 3 all over x same thing as 1 all over x times 3. So let me test if they actually approach the same thing. Do you get it? So okay, let me even do it like this to make it easier for me. We have two definition of it, so I can use the second one. So the second one says that when you have 1 all over x raised power 1 all over x, 1 plus x raised power 1 all over x, the limit as s tends to 0 is actually e, right? Do you get it? The only difference is that for the first one is 1 all over 1 plus x all over x abi. So when s for this case, when you are using 1 over x, when s tends to infinity, 1 over s tends to 0. When s tends to 0, this s that is there also tends to 0. These two that is inside the bracket are tending to the same thing. So this one to 1 all over s, when 1 all over s tends to 0, that is 1 all over 0, that is infinity. This s is also infinity in this way, so it's the same definition literally. So with this knowledge now, I will now say that let my 3 all over x be equal to something. Let me say it's equal to a. So that means that my x is actually equal to 3 all over a. Why I'm doing this is because I want to write it in form of 1 plus 3 all over x. I will now replace it with a. This x I will now replace it with 3 all over a. Do you get it? So I will now use that. Let me cancel this. I have 1 plus a all over 3 all over a, right? So that will now be 1 plus a all over 1 all over a times 3. Do you get it? So I can now use that definition. Remember that my 3 all over x is equal to a. So as the x tends to infinity, so that will be 3 all over infinity. My a tends to what? A number divided by a very, very big number will give me something very close to 0. So my a tends to 0 at that point. So I can now say limit of, as a tends to 0, because my 3 all over x tends to infinity, a tends to 0, of 1 all over a raised power 1 all over a multiplied by 3, something like this. So but this 3 you can bring it out. So first, let's first deal with the inputs. As a tends to 0 of 1 plus a all over 1 all over a is the definition of e. So that would be everything inside here is e, then raised power 3. So the answer is raised power 3, which is c. Then the next one I have in 1 plus x all over x. Of course, to make it easier for us. So let me do it like this. Um, since if you do in 1 plus x, that will be in 1 plus 0. So that will be in 1. In 1 is equal to 0. When you do all over x is equal to 0. So it's 0 all over 0. So you can use your L'Hopital rule. So when you differentiate in 1 plus x, of course, you first differentiate this input, this stuff that is inside, because it's also changing. So when you differentiate 1 plus x, that will give me when you differentiate 1, that is 1. When you differentiate x 1, so you multiply 1 times. You now differentiate this in x as a whole. If you want to differentiate in x, you are going to get 1 over x. So when you differentiate in 1 plus x, you are going to get 1 over x, 1 plus x. But mind you, you must multiply it by what you differentiated inside, which is 1. That is how to use the product rule. Do you get it? So this is 1 plus x. So then divided by x is same thing as writing divided by x like this. So I have 1 times 1, that is 1, all over 1 plus x. Then divided by is same thing as 1 all over x. This divided by x same thing as divided by x all over 1. The numerator to denominator, denominator to numerator, to change multiplication to division. So I now have 1 times 1, 1 into bracket 1 plus x into bracket x 1 plus x multiplied by x, and my x tends to 0. Sorry, I forgot to. I will differentiate the numerator and the denominator. So when I differentiated this x, it was supposed to give me 1. So this one is not there. So it will have been divided by 1. Anything divided by 1 is still 1. So it will have been 1 all over 1 plus x. And my x is equal to 0. So that will be 1 all over 1 plus 0. So 1 over 1 is equal to 1. So my answer is 1. Let me do it again. When I differentiated in x, first of all, differentiate the input. That is 1 plus x. When I differentiate it, give me 1. And in x, taking it as 0, when you differentiate in x, you get 1 plus x. 1 all over 1 plus x. Then when you differentiate this x, it will give you 1. So the numerator is actually divided by 1. So 1 times 1 is 1. Then your x tends to 0. So x is equal to 0. Then multiply by 1 or divided by 1 anyhow. It's still the same thing. Then 1 all over 1 plus 0. 1 plus 0 is 1. 1 divided by 1 is 1. So my answer is 1. No, sorry, it's 1 I want to pick. So for this one, in of 1 plus 4x all over x, you can still use delta rule for this one. So you just differentiate this. For this 1 plus 4x that is there, first differentiate it. That is how you, it's product rule we are using, but I don't want to write the formula. Just know you differentiate what is inside, because this in x is changing. 1 plus 4x inside of it is also changing. So you first consider the small change, 1 plus 4x. When you differentiate 1 plus 4x, we are going to get 0 plus 4. So you write that 4 and differentiate in 1 plus 4x as a whole. That is going to give you 1 over 1 plus 4x. When you differentiate x is just 1, that is gone. So that is 4 all over 1 plus 4x. Your x is equal to 0. So 4 times 0 is still 0. That is 4 all over 1. So my answer is 4. So moving to the next one, we'll differentiate again. When you differentiate our in x, we are going to get 1 over x. When you differentiate x, it's going to give me 1. So that is why I ignore that. That is 1 over x. And if I differentiate the denominator, which is x minus 1, when I differentiate x, that is 1. When I differentiate 0, that is 1. So that will be 1 all over 1. Did you get? So that is 0. And mind you, why I can use that is because, okay, 1 over 1 is 1, rather, sorry. That is one. Why I can use that is because I've tested my x equal to 1 and I see that in 1 is equal to 0 and at the same time 1 minus 1 is equal to 0 is indeterminate. That is why I use my neutral zone. So don't be too relaxed to just be using it if the numerator and denominator is not equal to 0 or is not equal to infinity. So my answer is 1. So for the next one, 48, I have this guy in x in 1 plus x. So let me just differentiate the upper and the lower to make it easier for me. When I differentiate in 1 plus x, I've done that before. I got, so I just use it directly.